Right, so we're going to take a look at proofs. As you can see, it's a higher topic, so it will be found in the higher paper. And if you're looking to attain those level 7s and above, you need to know how to do this because this will set you apart in your GCSE examinations. So let's get into it. So if n is an integer, which is a number, 2n will always be even. 2n is basically in the 2 times tables because anything you times by 2 will give you an even value. And that can be shown in the results of your 2 times table. If we look at what we looked at previously, even times an odd is an even, and an even times an even is an even. So this also proves the point that 2n will always be even. Okay, so 2n plus 1 and 2n minus 1 will always be odd. Okay, and why this is the case is that 2n is even. So if you add 1 to an even number, that gives you an odd number. And again, if you take away 1 from an even number, that will also give you an odd number. This is because numbers go in an odd and even pattern. So 1, 2, 3, 4, 5, 6 goes in an odd, even, odd, even, odd, even arrangement. So this is why this is correct. Again, if we utilize what we looked at earlier, even plus an odd is an odd, and an odd plus an even is an odd, which proves the point that 2n plus 1 and 2n minus 1 will always give you an odd result. 2n is even algebraically, and that 2n plus 1 and 2n minus 1 is odd. So now we're going to look at how we can utilize or use these to actually answer some questions. Right, example 1. Prove whenever 2 even numbers are added, the total is also an even number. So yes, you could approach it like this. You could say 2 plus 2, they're both even numbers, and that gives you an even number 4. Or 6 plus 4, they're also both even numbers, and they give you 10. Or 100 plus 100, which are both even numbers, which give you 200. So yeah, you can give some examples of even numbers and say that if you add these even numbers together, you get an even number. But we need to show this algebraically, so I'm about to show you how. Now, to get this done algebraically, you need to write down 2n. Now, we need to start with 2n because we've seen earlier that 2n is how we show an even number using algebra. Anything times 2 will always be even. Because we need 2 even numbers in this question, I'm also going to add another 2, but instead of n, I'm going to use m. So we can see that they're different numbers. One of them is 2n, which is one number, and the other one is 2m. Now, if you've been following this series, you should know that you can't add together 2n plus 2m because they're both different terms. They're part of different groups. So what we're going to do here is factorize. We're going to factorize this expression by taking out a 2. So we're going to take out a 2, and we'll have n plus m inside the brackets. And this is basically the answer because we've proven that you've added 2 even numbers together, 2n plus 2m, and it still gives you an even number, 2n plus m. Doesn't matter what's inside these brackets, but if you're timesing by 2 at the end, we're always going to have an even number. Okay, so next question. Example 2. Prove that the product of 2 odd numbers is always odd. So again, we could use the technique of doing 3 times 5, which is equal to 15, which is an example, and 7 times 3, which is equal to 21. And both of these answers are odd numbers. However, we need to show this algebraically. Now, to show this algebraically, we will write one odd number, which is 2n plus 1, like we've seen earlier. You have an even plus 1, which gives you odd. We'll put that in brackets. And what product means, if you haven't caught on to that, it means timesing. So we're going to multiply this by another odd number. And in this case, I'm going to call it 2m plus 1, okay, in brackets. Now, why I'm using 2m instead of 2n is so that we can see that there are 2 different odd numbers. Now we're just going to expand the brackets like we've learned earlier. So we're going to expand 2n times 2m, which will be 4nm. 2n times 1, which is plus 2n. 1 times 2m, which is plus 2m. 1 times 1, which is plus 1, right? We are now going to focus on this bit of the expression, and we're going to factorize this bit. Now, when factorizing this, we can take out a 2 from everything, and that's the only thing we can take out. So now we have 2nm plus n plus m in brackets plus 1 on the outside. And this whole thing is odd, because if you look closely at this bit, 2 open bracket 2nm plus n plus m, right? It looks something like this, 2n. This bit inside is just an integer, which is n, and then we're adding 1. So therefore, this whole expression we have now is our answer, and it's odd because we have 2 multiplied by the brackets, which is even, plus 1, which is odd, which gives you an odd. So example 3, x is an odd number. Prove 3x plus 2 is always an odd number. So we're going to make x equal to 2n plus 1, because earlier we've seen that 2n plus 1 is how we show an odd number using algebra. So now I'm going to replace the x here with 2n plus 1. So 3 2n plus 1 plus 2. Okay, this becomes 2n plus 1 times by 3 instead of 3 times x, because that's what's happening here. 3x is the same as 3 times x. So we're replacing the x with 2n plus 1. And I put it in brackets because you probably guessed it, we're going to have to expand here. So we have 6n plus 3 plus 2. And what I'm going to do here now is add the 3 and 2 together. So we have 6n plus 5. Right, so I'm going to do something here. I'm going to split the 5 into 4 and 1. So it'll become 6n plus 4 plus 1. Now, why I'm doing that is because I want to factorize this bit of the expression. So factorizing this bit of the expression, we now get 2 3n plus 2 plus 1. And this is an odd number. This is our answer, because 2 times any number inside the brackets will always give you an even, and an even plus 1 will always give you an odd.